Hello, class. This is lesson 4.5, solving by adding. All right, we've been talking a lot about variables lately and how you can use a variable to try to solve an equation. Today, we're going to learn how to solve simple variable equations or equations that have variables in them using addition. Now, let's start at the beginning, a very good place to start. Let's say we had an equation that looked like this. You had a variable. Let's use a different variable today. Let's use b. When we say some number, we don't know what it is, b minus, let's say 5 equals 5. Well, most of us can probably figure out what b is already, right? It's 10. 10 minus 5 is 5. But that's not what we're trying to do today. What we're trying to do today is say, if I have a situation like this, an equation where I have a missing variable, and it's in a subtraction problem, how can I figure out what that is? Well, we need to do a couple things. We need to do what's called the inverse, I-N-V-E-R-S-E, the inverse of the operation. As we know, our operations are addition, subtraction, multiplication, division, and there's a couple others, but these are the four basic ones, right? Well, the inverse is simply the opposite. So for example, if you have addition, the inverse is subtraction. If you have subtraction, the opposite is addition. If I have, multiplication, the inverse is division. And if I had division, the inverse or the opposite is multiplication. Very simple. It's kind of intuitive. You already know these things, right? So when we're talking about this equation here, this b minus 5 equals 5, a simple way to do this is to try to isolate or get the variable by itself on one side of the equal sign. So for example, if I have b minus 5 equals 5, I want to do the opposite or the inverse of my operation. What's my operation? Well, it's the negative. So step one, identify the operation. And since I have a minus, I'm going to do, here's the operation, it's a negative, it's a minus. I'm going to do the opposite. Step two, do the opposite or the inverse. So the opposite of a negative is a positive, so I'm going to do positive 5. And because we're talking about equations, what I do to one side, I must always do to the other to keep balance, right? So if I add 5 here, I'm going to add 5 over here. And that's going to keep my scales balanced, right? So what do I get? I get b, negative 5 plus 5 cancels each other out, right? So that's a 0. There's nothing there. And then the equal sign drops. And 5, positive 5 plus 5 equals 10. So now there's nothing else I can really do, right? Because my variable is now isolated. We call that isolation, right? Isolation is the idea of being by yourself in a room or being alone. Isolation, or isolate the variable. Once you have the variable by itself, do you see how there's nothing with the b? That's how you know you're done. b is equal to 10. Now we have to prove that, right? And how do we prove it? Simple. We take what we know about our variable, which is that it equals to 10, and we replace it in the original equation to test it. So the original equation was, the original equation was b minus 5 equals 5. Now all I have to do is replace my variable with what I said it is, or what I found it to be, and we said b is 10, so 10 minus 5, I substitute the b for, or the 10 for b, and I have 10 minus 5. And what does 10 minus 5 equal? Well, 10 minus 5 is 5. Does 5 equal 5? Yes, it does. There you go. There you go. 10 minus 5 is 5. Does 5 equal 5 on both sides? Yes, it does. It is true. Therefore, B does in fact equal 10. And now I have solved my problem using addition. Oh, I didn't finish the title up here. By adding. There you go. All right. So again, step 1, identify what your operation is. If it's addition, use subtraction. If it's subtraction, use addition. Try to isolate the variable. The variable here was b. We're trying to get it by itself on one side of the equal sign, okay? And then you solve to where you get the variable by itself, where it's equal to one number. And then finally, you plug in that value to the original equation to test it. All right, let's try another problem. Let's try, here's a good one. We've got 12 equals 10 plus, and my favorite letter, z. So 10 plus something is equal to 12. Well, we all probably know it's 2, right? But how are we going to solve that? First, what we're going to do is we're going to arrange it in a way that we understand. If you don't understand it like this, feel free to put it in a different order, like so. You could say 10 plus z is equal to 12. Maybe you understand that format a little better, that's fine. And then you might even say, okay, how am I going to solve this, right? I can't subtract a z because that's not what we're dealing with. What I have to do is I have to say, okay, look, this is a positive 10, right? All I need to do is do the opposite of positive 10, which is, or the inverse of negative 10, which is, I'm sorry, the inverse of positive 10, which is negative 10. What I do to one side, I do to the other. So subtract 10, subtract 10. And then I solve it out. 10 minus 10 is 0, so they cross each other out. The z should be on one side of the equation by itself. What I do to one side, I have to do to the other. So 12, and the other, I'm talking about the other side, the equal sign. 12 minus 10 is 2. So now the variable has been isolated. Z is supposed to equal to 2. Now let's test that. How do I prove it? Well, all I need to do is rewrite the original equation, which is 12 equals 10 plus z. Then I substitute what I said the z value is, which is 2 in this case. Rewrite the equation one more time. Let's see if it's true. What is 10 plus 2? 10 plus 2 is in fact 12. Does 12 equal 12? Yes, it does. Therefore, we know it's true. Z does in fact equal 2 for this equation. Let's try one more. It's pretty intuitive, pretty simple. Oh, let's try a good one. Let's try, here's a nice one. If I have the letter n, n plus 8 is equal to 21. Now this one, you probably don't know it right off the top of your head, right? But still, the steps are simple. What I'm trying to do is I'm trying to get the n, the variable, by itself on one side of the equation, the left side in this case. So I look at it's n plus 8, and I say, okay, what's the inverse, the opposite of plus 8? Well, the opposite is going to be minus 8, right? So minus 8 on one side. What I do to one side, I do to the other. And then I try to solve it out. N just gets dropped. 8 minus 8 is 0. So that's nothing. Equals 21 minus 8. Let's think. 21 minus 8. Oof, oof, ooh. I believe that is, well, let's use our fingers, right? 8, 9, 10, 11, 3, right? So 13. All right? And of course, if you want to test that, you can do 21 minus 8, borrow, what's it called? 10 from here, put it over here. 11 minus 8 is 3, 1, 13. So I was right. All right. N equals 13. Clean this up. The 0 doesn't need to be put down again. So n is 13. So let's prove that. How do I prove it? All I need to simply do is rewrite the original equation. N plus 8 is equal to 21. Substitute what I know about n, which is 13 now. Does 13 plus 8 equals 21? Well, let's see. 13 plus 8, 13 plus 8, 8 and 3 is 11, carry the 1, 21, there you go. 21 equals 21. It checks out, it works. Therefore, we know for a fact that n equals 13. All right, so what do we know here today? We learned about the word inverse operations. Inverse operations are simply the opposite. The opposite of addition is subtraction. The opposite of subtraction, addition. Opposite of multiplication is division. The opposite of division is multiplication. We learned the word isolating the variable, which means to get it by itself on one side. Isolate the variable. And you're trying to get it to equal something on one side, right? And we use substitution to prove our answers. All right, hopefully that helps. We'll see you in the next video.